September 19, 1942. Richmond, California, Kaiser Shipyard No. 2. A German intelligence officer studying reconnaissance photographs from a Spanish agent noticed something unusual in the background of images showing Liberty ship construction. Small, boxy vehicles with vertical masts were moving cargo pallets that would normally require teams of longshoremen. The officer's marginal note, preserved in captured Abwehr files, read, "Motorized hand trucks, typical American excess. 6 men with block and tackle would suffice." Within 18 months, those same motorized hand trucks would help load 2,710 Liberty ships fast enough to render the entire German U-boat strategy mathematically impossible. The forklift, a machine so mundane it barely warranted mention in military assessments, would become the invisible weapon that won the Battle of the Atlantic, not through violence or sophistication, but through the simple act of moving cargo, faster than anyone had thought possible. The story begins not with naval warfare, but with warehouse floors and factory docks. In 1939, the forklift was still a relatively new invention, having evolved from basic lifting platforms in the 1920s to the recognizable fork-equipped vehicle by the mid-30s. Clark Equipment Company, Yale and Town Manufacturing, and Heister Company dominated a small market, serving warehouses and factories. Total American forklift production in 1939 barely exceeded 10,000 units annually. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. German military planners paid virtually no attention to cargo handling equipment. Their focus remained on combat vessels, aircraft, and armored vehicles. The mechanics of loading ships belonged to the civilian sphere, a logistical detail handled by traditional methods that had served maritime commerce for centuries. Longshoremen with hand trucks, winches, and cargo nets could load a freighter in 3 to 5 days. This was simply how things were done. The German Kriegsmarine's confidence in 1940 through 1941 rested on straightforward mathematics. Admiral Dönitz had calculated that 300 Type 7 U-boats, operating in coordinated Wolfpacks, could sink 700,000 gross registered tons monthly. Britain imported 47 million tons of supplies annually to survive. Sink enough ships faster than they could be replaced, and Britain would starve into submission within a year. The formula appeared elegant, even inevitable. Early U-boat successes seemed to validate Dönitz's calculations. During Operation Drumbeat off the American coast in early 1942, German submarines sank 609 ships, totaling over 3 million tons in just 8 months. Korvettenkapitän Reinhard Hardigan, commanding U-Own 23 off New York Harbor, wrote in his war diary, "It is almost unfair. 10 freighters burning within sight of Coney Island. The Americans have learned nothing from 2 years of European war." But something was happening in American factories and shipyards that would transform these calculations entirely. The convergence of 3 technologies, mass production methods, standardized cargo handling, and revolutionary shipbuilding techniques, would create a logistical capability beyond German comprehension. At the center of this convergence, largely invisible to military observers, was the forklift. The transformation began with Henry Kaiser's shipyards. Kaiser, a construction magnate who had never built a ship before 1940, approached shipbuilding with an industrialist's mindset rather than a maritime traditionalist's. When he toured his first shipyard in Richmond, California, in late 1940, he observed longshoremen manually loading equipment and supplies onto vessels, using methods unchanged since the 19th century. Teams of 6 to 8 men wrestled cargo nets, operated hand-cranked winches, and spent hours positioning heavy items in ship holds. Kaiser's question to his logistics chief was characteristically direct. How do automobile factories move heavy parts? The answer was forklifts. Within weeks, Kaiser had ordered 200 forklifts for his Richmond shipyards, not for ship construction itself, but for the invisible work that determined whether ships could be built at unprecedented speed, moving steel plates, transporting prefabricated sections, positioning equipment, and eventually loading completed vessels. The impact was immediate and dramatic. Tasks that required 8 longshoremen working a full shift could now be accomplished by one forklift operator in an hour. Steel plates weighing 3 tons, previously requiring elaborate rigging and dangerous manual positioning, could be lifted and placed, precisely by a single machine. Prefabricated ship sections, the key to Kaiser's revolutionary assembly line approach, could be moved rapidly from fabrication shops to assembly positions. Traditional maritime unions initially resisted. The International Longshoremen's Association saw mechanized cargo handling as an existential threat to their members' livelihoods. But the urgency of wartime production and the sheer scale of required output overwhelmed resistance. The federal government, through the War Production Board, actively encouraged forklift adoption. By mid-1942, every major American shipyard had integrated forklifts into their operations. German intelligence officers analyzing American industrial capacity in 1942 focused on dramatic, visible metrics: steel production tonnage, aircraft manufacturing numbers, tank assembly rates. They tracked the construction of new shipyards and noted the revolutionary prefabrication methods. But they completely missed the significance of cargo handling mechanization. The forklift remained invisible in their assessments, a trivial detail beneath the notice of serious military analysis. This blindness extended to German shipyards. The few forklifts operating in German ports and factories were typically older models, often captured from occupied territories. German industry focused on combat equipment. Resources allocated to material handling equipment were minimal. Traditional methods, labor-intensive but proven, continued to dominate German logistics. The first Liberty ship, the SS Patrick Henry, was launched on September 27, 1941. The vessel took approximately 245 days to build, far too long to meet wartime requirements. But within the hull of this first ship were the seeds of a revolution. The design featured standardized cargo holds with uniform dimensions, allowing for mechanized loading with minimal manual positioning. The holds were sized specifically to accommodate the 48-inch by 40-inch pallets that forklifts handled most efficiently. This standardization, seemingly minor, would prove strategically decisive. Traditional cargo ships featured holds of varying sizes and configurations, requiring skilled longshoremen to maximize space utilization through careful, time-consuming placement. Liberty ships sacrificed some cargo efficiency for loading speed. The holds were designed for forklift access, with smooth floors, minimal obstructions, and consistent vertical clearances. By early 1942, Kaiser's shipyards had refined their production methods to extraordinary efficiency. The construction time for Liberty ships dropped from 245 days to an average of 42 days. The SS Robert E. Peary, completed in just 4 days and 15 hours in November 1942, demonstrated the ultimate potential of these methods. But construction speed meant nothing if completed ships sat idle waiting for cargo. Traditional loading methods created a bottleneck. A Liberty ship's 10,000-ton capacity, when loaded conventionally, required 3 to 4 days of intensive longshoreman labor. Multiple ships completing construction daily at a single shipyard would create massive backlogs if loading proceeded at traditional speeds. The solution was mechanized cargo handling on an unprecedented scale. American ports underwent rapid transformation in 1942 and 1943. Forklift production, which had been 10,000 units annually before the war, exploded to over 70,000 units annually by 1943. Clark Equipment Company alone produced 33,000 forklifts during the war years. These machines flooded into American ports from New York to San Francisco, from New Orleans to Seattle. The standardization extended beyond the ships themselves to the cargo they carried. The War Department mandated pallet dimensions of 48 inches by 40 inches for most military supplies. Ammunition, food, equipment, spare parts, all were packaged on standardized pallets designed for forklift handling. This created a system where cargo could move seamlessly from factory floor to warehouse to truck to dock to ship hold, always on the same pallet, always handled by the same type of forklift. Loading times collapsed. A Liberty ship that would have required 72 to 96 hours to load using traditional methods could now be loaded in 24 to 36 hours using forklifts and palletized cargo. This wasn't a marginal improvement. It was a 3-to-1 to 4-to-1 increase in efficiency that multiplied the effective capacity of American ports. German naval intelligence began receiving disturbing reports about American port efficiency in mid-1942. Agents in neutral countries forwarded newspaper articles describing new cargo handling methods. One report from Lisbon in August 1942 included a photograph from an American magazine showing forklifts loading a Liberty ship. The intelligence analysis dismissed it as propaganda. Claimed loading times are physically impossible. Traditional maritime practice requires a minimum of 3 days for vessels of this tonnage. The reports, however, were not propaganda. They were conservative. By late 1942, experienced American dock crews using forklifts were routinely loading Liberty ships in under 30 hours. Some particularly efficient ports, like Oakland and Baltimore, achieved loading times of 24 hours or less. The implications were staggering. American ports could load ships as fast as Kaiser's yards could build them. This created a logistical multiplication effect that German planners had never anticipated. It wasn't enough that America could build ships faster than Germany. America could also load those ships faster than Germany could target them. U-boats achieved their highest success rates against ships in convoy. But convoys had to assemble, which meant loaded ships often waited days or weeks at anchor for convoy formation. Faster loading meant less waiting time, fewer targets congregated in vulnerable anchorages, and more ships at sea delivering cargo. The psychological impact on U-boat crews developed gradually. Early war patrols in 1940 through 1941 encountered older, slower, individually routed merchantmen. These ships, often decades old, represented the pre-war maritime economy. They were relatively easy targets, their routes predictable, their defences minimal. U-boat commanders wrote confidently of happy times when a single submarine could sink multiple ships per patrol. By mid-1942, U-boat commanders began noting changes in their patrol reports. More ships appeared. Convoys seemed to form more quickly. The intervals between convoy sailings shortened. Kapitänleutnant Herbert Werner, serving aboard U-230, wrote in his memoir, "We began encountering convoys of identical ships, all new, all American-built, sailing in formations that suggested endless supply. Where once we found half-empty convoys of aging vessels, we now faced walls of fresh-painted hulls." The turning point came in spring 1943. U-boat success rates, measured in ships sunk per submarine per patrol, began declining sharply. Simultaneously, Allied merchant ship availability increased dramatically. The mathematics that Dönitz had calculated so carefully inverted. Instead of sinking ships faster than they could be replaced, U-boats were now sinking ships slower than they were being built and loaded. German naval intelligence struggled to understand the mechanics of American logistical superiority. They correctly identified Liberty ship production rates, revolutionary shipbuilding methods, and massive industrial mobilization. But they missed the connecting element that made everything else possible: the forklift-enabled cargo handling system that ensured ships didn't sit empty waiting for cargo. A captured German intelligence document from May 1943, obtained from files in Kiel after the war, contains a telling analysis. American ship production confirmed at approximately 120 vessels monthly. However, utilization rates suggest insufficient port capacity to load vessels at this rate. Either production figures are exaggerated, or loading methods have improved beyond our estimates. The figures weren't exaggerated, and loading methods had indeed improved beyond German estimates. Forklifts, working in American ports 24 hours daily in 3 shifts, were moving cargo at rates German intelligence considered impossible. The standardized pallets, uniform ship holds, and mechanized handling created a system where the limiting factor was no longer loading time but convoy formation schedules. By summer 1943, American ports were loading Liberty ships so quickly that vessels sometimes completed loading before convoy assignments were finalized. Ships waited not for cargo, but for sailing orders. This represented a complete inversion of traditional maritime logistics, where cargo waited for ships rather than ships waiting for cargo. The human dimension of this transformation appeared in unexpected places. Margaret Rosie Thompson, a welder at Richmond Shipyard No. 2, later recalled, "We'd launch a ship on Monday, and by Thursday it would be gone, loaded and sailing with a convoy. We knew our welding had to be perfect because there was no time for repairs. The ships went from our hands to the ocean in days, not weeks." Forklift operators, previously low-status warehouse workers, became critical personnel in the American war effort. Training programs expanded dramatically. Clark Equipment Company established forklift training schools that graduated thousands of operators monthly. The military services, recognizing the strategic importance of cargo handling, created specialized quartermaster units trained specifically in mechanized loading operations. German forces got their first direct exposure to American cargo handling efficiency in North Africa in late 1942. After Operation Torch, Allied landings in Morocco and Algeria, German and Italian forces observed American logistics firsthand. The speed at which American forces unloaded ships and moved supplies forward astonished Axis observers. Oberst Wolfgang Müller, commanding a reconnaissance battalion opposing American forces in Tunisia, wrote in his diary in January 1943, "The Americans land supplies faster than we can target them. Their cargo vessels discharge in hours what would take our forces days. They employ motorized lifting devices that replace dozens of laborers. This is not warfare as we understand it. This is industrial process applied to military operations." These observations, when forwarded to German High Command, received skeptical responses. The concept of mechanized cargo handling as a strategic weapon simply didn't register with officers trained in traditional military theory. Logistics was support, not strategy. The real war happened on battlefields, not loading docks. This conceptual blindness proved fatal. By early 1943, the statistical evidence became overwhelming. American merchant ship availability, measured in total tonnage, began increasing, despite continuing U-boat successes. In March 1943, U-boats achieved one of their greatest tactical victories, sinking 21 ships from convoys HX-2, 29, and SC-1, 22. But that same month, American shipyards launched 120 new vessels, and American ports loaded and dispatched over 200 ships in various convoys. The mathematics were inescapable. Even successful U-boat operations couldn't sink ships faster than American industry could, build and load them. Dönitz's carefully calculated tonnage war had encountered an enemy capable of producing tonnage at rates he had considered impossible, and enabling this production was a machine so mundane, so apparently trivial, that German military intelligence had never seriously assessed its strategic significance. The forklift revolution extended beyond simple loading speed. It fundamentally changed what could be loaded and how quickly military operations could be supplied. Traditional cargo handling required relatively uniform cargo that could be managed with nets and winches. Odd-shaped items, heavy equipment, and specialized military hardware required custom rigging and extensive time. Forklifts, combined with proper palletization, could handle almost anything. Jeeps were driven onto reinforced pallets and lifted directly into holds. Artillery pieces were positioned on heavy-duty pallets and loaded without complex rigging. Ammunition of all types, from rifle cartridges to artillery shells, moved on standardized pallets that forklifts could stack efficiently in ship holds. The versatility meant that Liberty ships could carry extraordinarily diverse cargoes without the traditional penalties in loading time. This versatility had direct battlefield implications. American forces in every theater, from North Africa to the Pacific, received supplies with a consistency and speed that enemy forces couldn't match. German units in North Africa, for instance, famously suffered from supply shortages despite Rommel's tactical brilliance. American and British forces facing similar supply line challenges consistently maintained better supplied positions. The difference wasn't just in total supply production, it was in the efficiency of moving supplies from factory to front. Forklifts represented one link in a chain of mechanization that made American logistics uniquely effective. Supplies moved from factories to warehouses to trucks to ports to ships to overseas ports to forward depots, all on standardized pallets handled by standardized equipment operated by standardized methods. German logistics, by contrast, relied heavily on manual labor at each transfer point. Supplies moved from factory to warehouse by hand, from warehouses to rail cars by hand, from rail cars to trucks by hand, from trucks to ports by hand. Each transfer required time, labor, and created opportunities for damage or loss. The inefficiency compounded at each stage, creating delays and waste that undermined even successful production efforts. Captured German logistics officers, interrogated about supply problems, consistently mentioned labor intensity as a limiting factor. One quartermaster officer, captured in Tunisia in May 1943, stated, "We calculated tonnage moved per man-hour. Our calculations showed American forces moved 3 to 4 times more cargo per worker than our forces. We assumed this reflected larger labor forces. Only later did we learn about their mechanization." The statistical comparison became clearer as more data emerged during the war. American ports using forklifts and palletized cargo achieved loading rates of approximately 20 to 30 tons per man-hour. German ports using traditional methods achieved 6 to 8 tons per man-hour. The 3-to-1 to 4-to-1 efficiency advantage meant American ports could load dramatically more cargo with similar-sized workforces. This efficiency gap extended to ship turnaround times. A Liberty ship arriving at an American port could discharge its ballast, take on cargo, and depart in as little as 48 hours. The same ship at a German-controlled port, assuming it somehow reached one, would require a week or more for similar operations. The difference compounded across thousands of voyages and hundreds of ships, creating an enormous strategic advantage. The U-boat forces' morale began cracking under the weight of these accumulated disadvantages in mid to late 1943. Submarine crews, already facing improved Allied anti-submarine warfare, increasingly reported encountering endless streams of new ships in every convoy. The psychological impact of sinking a freighter only to see 3 more identical vessels in the same convoy proved devastating. Oberleutnant zur See Hans Joachim Förster, pulled from the water after Uone 89 was sunk in April 1943, spent several weeks aboard the Liberty ship James Magoffin before reaching port. In his post-war memoir, Förster recalled, "The ship was so new that instruction manuals remained in plastic wrapping. Everything was fresh, clean, functional. The American crew, when they learned I was a U-boat officer, actually pitied me." One sailor said, "We're building 10 ships for every one you sink. This war's already over, you just don't know it yet." I thought he was boasting. Later, I learned he was, if anything, understating American production. What Förster and other captured U-boat personnel witnessed during their time on American vessels was the tail end of a logistical system that began with forklifts, moving pallets in warehouses, and ended with those same pallets being unloaded at British, Soviet ports. The system's efficiency depended on mechanization and standardization at every stage, creating speed and reliability that traditional methods couldn't match. By late 1943, German naval intelligence had accumulated enough data to recognize the scale of American logistical superiority. A comprehensive report compiled in November 1943, captured after the war from Kriegsmarine files, contained a section on Allied cargo handling methods. The analysis noted extensive use of motorized lifting equipment and standardized cargo packaging systems as factors in American port efficiency. But the report's recommendations revealed continued German blindness to the strategic significance. It suggested that Germany study American methods for potential post-war adoption, rather than recognizing these methods as current threats requiring immediate countermeasures. The conceptual gap remained unbridgeable. German military culture couldn't accept that something as mundane as cargo handling equipment could be strategically decisive. This blindness persisted even as the mathematics of defeat became undeniable. In December 1943, Dönitz presented updated statistics to Hitler. U-boats had sunk 167 ships, totaling 940,000 tons in the last quarter. American shipyards had launched over 300 ships, totaling approximately 2.5 million tons in the same period. The net Allied gain exceeded 1.5 million tons, and the gap was widening monthly. Hitler, characteristically, blamed U-boat commanders for insufficient aggression and ordered continued attacks despite mounting submarine losses. Dönitz, more realistic, recognized the impossibility of the situation. But neither leader grasped that part of their defeat had been welded together in Clark Equipment Company factories in Michigan and driven across American dock by operators trained in weeks rather than years. The forklift's contribution to Allied victory remained invisible not just to Germans, but to many Allied observers as well. Histories of the Battle of the Atlantic focused on dramatic submarine hunts, convoy battles, and technological innovations like radar and sonar. The unglamorous work of cargo handling rarely appeared in combat narratives. Yet, without forklifts enabling rapid loading, the Liberty ships that won the tonnage war would have sat idle in ports, their revolutionary construction speed meaningless. The strategic multiplication effect of forklift-enabled logistics became most apparent when examining the complete supply chain from American factories to the European battlefield. In early 1944, as Allied forces prepared for the Normandy invasion, the logistical challenge seemed overwhelming. Operation Overlord would require landing 150,000 troops on D-Day, followed by sustained supply of growing forces fighting across France. Traditional logistics calculations suggested this was impossible. The required tonnage of supplies, measured in millions of tons delivered over months, exceeded any previous military operation in history. Staff officers planning the invasion studied cargo capacity, port availability, and shipping schedules with mounting anxiety. The numbers barely worked, even with optimistic assumptions. What made Operation Overlord feasible was the hidden efficiency built into American logistics. Every supply item moved from factory to warehouse, to port, to ship on standardized pallets. Forklifts at each stage eliminated traditional transfer delays. Ships loaded in hours rather than days. The cumulative time savings across thousands of shipments created capacity margins that made the invasion possible. German intelligence, monitoring Allied preparations, recognized enormous supply build-ups in British ports. They observed thousands of vehicles, millions of tons of ammunition, vast stockpiles of food and fuel. What they couldn't see, and failed to understand, was the systematic efficiency that had moved these supplies across the Atlantic so quickly. The supplies themselves were visible. The system that delivered them remained invisible. When Allied forces landed in Normandy on June 6, 1944, German defenders faced an enemy unlike any they had encountered. American units advanced with supply lines that functioned with almost mechanical reliability. Captured German officers repeatedly mentioned American logistical superiority in interrogations. One Panzer commander stated, "We calculated that American forces would outrun their supplies within a week. Instead, they maintained offensive operations continuously. Their logistics appeared limitless." This logistical limitlessness rested substantially on cargo handling efficiency. Liberty ships crossing the Atlantic, loaded with supplies in American ports in 30 hours, sailed in convoys that now faced minimal U-boat threat and discharged their cargoes at British ports in similar timeframes. The artificial Mulberry harbours constructed off Normandy beaches incorporated forklift-accessible design, allowing rapid discharge even without traditional port facilities. By summer 1944, the U-boat force had been effectively defeated. Monthly sinkings had dropped below 100,000 tons, while Allied ship construction exceeded 2 million tons monthly. The tonnage war, which Dönitz had believed winnable in 1939, had become a catastrophic defeat. And contributing to this defeat, in ways German submariners never fully understood, were tens of thousands of forklifts moving pallets in hundreds of American ports. The human stories behind these statistics reveal the personal dimension of technological change. Robert Henderson, a forklift operator at the Port of New York, later recalled his wartime experience. "I worked the night shift, 10 p.m. to 6 a.m., loading Liberty ships, we had a rhythm. You'd pick up a pallet, drive it into the hold, position it precisely next to the previous pallet, drive out, grab the next one. Hour after hour. We knew every pallet we loaded meant supplies for troops fighting in Europe. Some nights we'd load an entire ship in a single shift. The old-timers, longshoremen who'd worked the docks for decades, would watch us and shake their heads. They remembered when loading a ship took a week. The longshoreman's perspective reflected the magnitude of change. Traditional cargo handling had been skilled labor requiring years of experience. Workers learned to judge weights, balance loads, rig complex pulley systems, and work cooperatively in teams. The forklift reduced this complexity to basic vehicle operation. A worker with minimal training could achieve productivity that would have required a crew of experienced longshoremen using traditional methods. This democratization of productivity proved strategically crucial. America could rapidly expand its logistics workforce by training new workers quickly, rather than relying on limited numbers of experienced longshoremen. During the war, American ports employed over 200,000 workers in cargo handling roles. Most had been trained in weeks or months. Traditional methods would have required decades to develop such a workforce. German ports, still relying predominantly on manual methods, faced opposite pressures. Experienced dock workers were increasingly conscripted into military service. Replacement workers, often elderly, men, women, or forced laborers, lacked the skills for efficient manual cargo handling. German port productivity declined throughout the war, even as demand increased. The contrast appeared starkly in comparative statistics. In 1943, American ports handled approximately 60 million tons of cargo for military purposes. German ports handled approximately 18 million tons. The 3-to-1 advantage reflected not just differences in total economic capacity, but fundamental differences in operational efficiency enabled by mechanization. Captured German logistics officers, when shown American port operations after the war, expressed astonishment at the mechanization level. General Major Friedrich Schulz, former quartermaster of Army Group Center, visited the port of Baltimore in 1946 as part of a U.S. Army intelligence study. His recorded comments are revealing. I counted 47 motorized lifting devices operating simultaneously in a single cargo area. Each replaced what we would have considered a full squad of workers. This mechanization explains what we could never understand during the war: how American forces maintained supplies despite supply lines stretching thousands of miles. The forklift's impact extended beyond European operations. In the Pacific Theater, where supply lines stretched even further, and traditional port facilities were often non-existent, mechanized cargo handling proved equally crucial. American forces landing on Pacific islands brought forklifts ashore in early waves, establishing mechanized cargo operations on beaches within hours of initial landings. Japanese forces, observing American logistics during their defensive operations, noted similar patterns to those German forces had witnessed in Europe. American units demonstrated supply availability that Japanese commanders considered impossible given the distances involved. The explanation, again, lay partially in systematic efficiency, beginning with forklift-enabled cargo handling. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The statistical evidence for the forklift's strategic importance appears in production and utilization data. American forklift production during the war years, 1941 through 1945, totaled approximately 220,000 units. These machines operated in factories, warehouses, ports, and forward supply depots across every theater. Each forklift replaced an estimated 8 to 12 manual workers for most cargo handling tasks, creating effective labor multiplication of over 1.5 million additional workers. This labor multiplication occurred precisely when America faced competing demands for manpower. Millions of men served in combat roles. Millions more worked in factories producing war material. The ability to achieve extraordinary logistical throughput without proportional labor allocation freed workers for other critical tasks. Without mechanization, American logistics would have required far larger labor forces, reducing industrial, production capacity and military strength. German attempts to counter American logistical advantages focused on attacking loaded ships at sea or in port. U-boats continued hunting convoys despite mounting losses. The Luftwaffe attempted port strikes against British harbours, but these efforts targeted the visible manifestation of American logistics, the loaded ships, rather than the system creating the advantage. Even successful attacks couldn't significantly impact overall supply flow when replacement ships loaded and sailed within days. The futility of this approach became apparent in U-boat loss rates. In 1943, U-boats lost exceeded U-boats commissioned for the first time. The loss rate accelerated in 1944 and 1945. By war's end, of 40,000 men who served in U-boats, 30,000 had died, a 75% casualty rate. They had fought magnificently for a strategy that mathematics had doomed, opposed by an industrial, the system they never fully understood. Kapitänleutnant Peter Kremer, commanding U-333 and one of the few U-boat commanders to survive the entire war, later wrote, "We thought we were fighting the British and American navies. Only after the war did I understand we were fighting American factories, American shipyards, and yes, even American warehouse equipment. Every Liberty ship we sank was replaced by 3 more, built and loaded faster than we could reload our torpedo tubes. It wasn't a battle. It was an industrial process defeating a military force." The post-war recognition of mechanized logistics' importance influenced military doctrine across all nations. The Soviet Union, which had received thousands of American trucks, jeeps, and other equipment through Lend-Lease, also received forklifts and adopted American cargo handling methods. British forces, having worked alongside American logistics throughout the war, similarly mechanized their supply operations. Even France and other liberated nations adopted American logistics practices as they rebuilt. Germany, divided and occupied after 1945, underwent thorough re-education in modern logistics. American and British occupation authorities introduced mechanized cargo handling to German ports. The efficiency improvements were so dramatic that by the 1950s, German ports operating with forklift-based systems achieved productivity levels exceeding their wartime performance by factors of 3 to 4. The forklift industry itself underwent massive expansion during and after the war. Companies like Clark Equipment, which had been relatively small manufacturers before 1940, emerged as major industrial corporations. The wartime experience proved the forklift's value across virtually every industry. Post-war commercial demand exploded as factories, warehouses, and shipping companies recognized the efficiency gains. By 1950, annual American forklift production exceeded 100,000 units, 10 times the pre-war rate. The machines spread globally, transforming cargo handling worldwide. The standardized pallet, designed to work with forklifts, became ubiquitous in global commerce. The 48-inch by 40-inch pallet dimension established during World War II remained an international standard into the 21st century. The Liberty ship's design, with cargo holds optimized for forklift-loaded palletized cargo, influenced merchant ship design for decades. Post-war cargo vessel specifications routinely included requirements for mechanized loading compatibility. The efficiency advantages proved so significant that traditional cargo handling methods virtually disappeared from modern shipping by the 1960s. The strategic lessons extended beyond specific technologies. The forklift's decisive impact demonstrated that warfare had fundamentally changed. Industrial capacity, logistical efficiency, and systematic organization increasingly mattered more than traditional military virtues like courage and tactical skill. The nation that could build, move, and supply faster would likely prevail regardless of battlefield performance. This lesson appeared repeatedly in subsequent conflicts. During the Korean War, American logistical superiority enabled sustained operations despite challenging supply lines. In Vietnam, American forces maintained supply availability that North Vietnamese commanders found incomprehensible given the distances and conditions. The pattern established in World War II, where systematic efficiency trumped traditional advantages, continued through subsequent decades. The human dimension of this transformation often appeared in unexpected ways. Dorothy Miller, who operated forklifts at the Port of Oakland during the war, later became one of the first female warehouse managers in California. In a 1985 interview, she reflected, "The war taught us that mechanical advantage could replace physical strength. I could operate a forklift as well as any man, moving cargo that would have required teams of strong workers before. That changed expectations about what women could do in industry." This democratization of physical labor through mechanization had broader social implications beyond military logistics. The forklift, like many wartime technologies, proved that appropriate tools could eliminate traditional barriers based on physical strength or specialized skills. The post-war expansion of mechanization across all industries owed much to lessons learned during wartime logistics operations. For the German military leadership captured and interrogated after the war, the forklift represented one of many American advantages they had failed to appreciate. Gross Admiral Dönitz, during Nuremberg tribunal proceedings, was questioned extensively about the U-boat campaign's failure. His answers focused on tactical factors: improved Allied anti-submarine, warfare, air cover, escort vessels, and intelligence advantages from decoded Enigma messages. When American prosecutors presented statistics about Liberty ship production and loading efficiency, Dönitz initially dismissed them as irrelevant to military analysis. Only after extensive interrogation did he acknowledge, "We calculated ship construction rates, but never adequately considered port capacity and loading efficiency. If the Americans could build ships but not load them quickly, our strategy would have remained viable. We failed to understand that their entire logistics system, from factory to front line, had been mechanized and standardized in ways we never achieved." This admission, recorded in trial transcripts, represented a broader recognition among German military leaders that they had fundamentally misunderstood modern warfare's nature. The Wehrmacht had prepared for tactical and operational excellence, achieving both in many battles. But strategic success, increasingly, required industrial and logistical superiority that Germany simply lacked against opponents like the United States. The forklift story also illuminates how technological change occurs and diffuses. The forklift wasn't invented during World War II. It had existed since the 1920s. What changed was the systematic application of the technology at scale, combined with complementary innovations like standardized pallets and ship designs optimized for mechanized loading. Innovation often requires not just inventing new technologies, but recognizing and exploiting existing technologies' strategic potential. German industrial leaders after the war frequently noted that they had known about forklifts and mechanized cargo handling. Several German companies manufactured similar equipment. What Germany lacked wasn't technological knowledge, but systematic integration of the technology into military logistics. The equipment existed, but the organizational structure and doctrinal understanding to use it effectively did not. This pattern repeated across many wartime technologies. Germany often possessed equivalent or superior individual technologies, radar, jet engines, rockets, but failed to integrate them systematically into effective military systems. America, by contrast, excelled at taking adequate technologies and deploying them systematically at an overwhelming scale. The forklift exemplified this approach. Good enough technology, properly integrated, deployed in massive numbers. The psychological impact of facing systematically superior logistics appeared in German soldiers' letters and diaries throughout the war. A recurring theme was bewilderment at American supply abundance. German units, often short of ammunition, fuel, and food, captured American positions and found vast stockpiles of supplies. The contrast demoralized German soldiers, who understood their side was losing the logistical war. Gefreiter Hans Becker, an infantry soldier captured in France in August 1944, described American supply dumps to interrogators. "We found warehouses full of supplies, organized perfectly, everything on wooden platforms that their vehicles could lift entirely. Ammunition, food, medical supplies, spare parts, all stacked systematically. Our supply dumps were chaos by comparison. Everything handled manually, constant searching for specific items. Seeing their organization, I understood why they were winning. This organizational superiority, built on mechanization and standardization, created multiplicative advantages. Better supplied soldiers fought more effectively. Faster moving supplies enabled more aggressive operations. Reliable logistics allowed commanders to plan confidently, knowing their plans wouldn't collapse from supply failures. The cumulative effect made American and British forces increasingly effective as the war progressed, while German effectiveness degraded. The forklift's contribution to this superiority remained largely invisible to contemporaries, but becomes clear when examining the complete logistics chain. Every pallet loaded onto a Liberty ship by a forklift in an American port represented supplies that would reach frontline soldiers days or weeks sooner than traditional methods would have allowed. Multiplied across millions of tons of cargo and thousands of voyages, the time savings accumulated into strategic advantage. By 1945, as Germany collapsed, the statistical evidence of American logistical dominance was overwhelming. American forces in Europe consumed approximately 35,000 tons of supplies daily. German forces, defending their homeland, struggled to maintain half that consumption rate despite shorter supply lines. The difference reflected not just damaged German infrastructure, but fundamental inefficiencies in German logistics that mechanization would have addressed. The final irony appeared in immediate post-war Germany. As occupation forces, organized relief supplies for German civilians facing starvation, American logistics officers introduced forklift-based cargo handling to German ports and distribution centers. The efficiency improvements were so dramatic that German logistics personnel who had struggled with wartime supply problems expressed bitter humor about their previous methods. One German port manager in Hamburg, observing American forklift operations in 1946, was recorded stating, "In 10 minutes, I watched them move more cargo than our workers could move in a day during the war." Had we possessed this equipment and understood these methods, perhaps our military would have starved less frequently, though, of course, that would have merely prolonged our inevitable defeat. This recognition that even if Germany had adopted American logistics methods, defeat was inevitable, reflected the broader reality. The forklift wasn't a magic weapon that alone won the war. It was one component of American, industrial and organizational superiority that collectively proved overwhelming. But as a component, it was crucial, enabling the rapid loading that made Liberty ship mass production strategically meaningful. The 2,710 Liberty ships, built between 1941 and 1945, represented the visible triumph of American shipbuilding. But each of those ships' strategic value depended on rapid loading, which in turn depended on forklift-enabled mechanized cargo handling. Without forklifts, Liberty ships would have been less valuable. Without Liberty ships, forklifts would have had fewer targets for their efficiency. Together, they created a system that rendered the U-boat threat mathematically irrelevant. For the U-boat crews who survived the war, this realization came gradually. Many initially believed they had been defeated by superior Allied anti-submarine technology, radar, sonar, depth charges, and escort tactics. These factors certainly mattered, but deeper analysis revealed that even perfect U-boat tactics couldn't overcome the fundamental mathematics of American production and logistics. Kapitänleutnant Erich Topp, one of Germany's most successful U-boat commanders with 35 ships sunk, addressed a veterans' reunion in 1975. "Gentlemen, we were magnificent warriors fighting an impossible battle. Every torpedo hit was meaningless when the enemy built 3 ships to replace the one we sank, and they loaded those ships faster than we could reload our tubes. We hunted convoys while they operated an industrial assembly line. Looking back, I wonder if our courage would have been better spent building factories than attacking ships." This recognition that industrial capacity mattered more than martial courage was perhaps the war's harshest lesson for German military culture. The Wehrmacht had cultivated an ethos of tactical excellence, individual initiative, and warrior spirit. These qualities, produced remarkable battlefield successes, but proved inadequate against opponents who approached warfare as an industrial process. The forklift symbolized this difference perfectly. It was unglamorous, mechanical, operated by workers with minimal training, and completely unimpressive to military observers focused on combat power. Yet, its systematic deployment created strategic advantages that German tactical excellence couldn't overcome. The humble forklift, moving pallets on dock, contributed more to Allied victory than many dramatic weapons systems. The story of Allied victory in World War II typically focuses on dramatic weapons, aircraft carriers, bombers, tanks, yet one of the most decisive factors in defeating Nazi Germany and Imperial Japan was far more mundane: the forklift. This unglamorous piece of industrial equipment, combined with systematic cargo handling procedures, created logistical advantages so overwhelming that Axis forces could not overcome them regardless of tactical brilliance or fighting spirit. By 1943, as Liberty ship production reached peak efficiency, American ports revolutionized cargo handling through what became known as the Baltimore method. This systematic approach divided each Liberty ship's cargo space into zones, with dedicated forklift operators working simultaneously in a single hold. Each operator became intimately familiar with their zone's specific dimensions and requirements. Pallets arrived in predetermined sequences, optimized for both loading efficiency and unloading priorities at destination ports. Supplies needed last were loaded first. Priority materials went in last for immediate access upon arrival. This choreographed precision reduced loading time for a standard 10,000-ton Liberty ship to an average of 28 hours by mid-1943, the fastest recorded loading the SS James B. Weaver, in September 1943, completed in just 19 hours and 42 minutes, taking on 9,800 tons of mixed military cargo. German naval intelligence dismissed these reports as propaganda designed to demoralize U-boat crews. A Kriegsmarine analysis from October 1943 stated that reported loading times of 20 to 30 hours contradict all maritime experience. German intelligence was wrong. The times were accurate, even conservative. What German observers couldn't grasp was that American ports had fundamentally reimagined cargo handling. Traditional methods treated each item individually, requiring skilled judgment about placement, weight distribution, and securing. Palletized cargo with forklift handling reduced these complex decisions to systematic processes that semi-skilled workers could execute rapidly. Each pallet carried identification marking its contents, weight, destination, and priority level. Forklift operators didn't need to know what they were loading, only where each pallet belonged. This abstraction created enormous efficiency. Traditional longshoremen required years of experience. Competent forklift operators could be trained in 2 to 4 weeks. By late 1943, over 30,000 certified forklift operators worked in American military logistics, with thousands more in civilian industries. Germany possessed no equivalent training infrastructure. The few forklifts in German ports operated as isolated equipment rather than components of integrated systems. The systemic difference appeared starkly when American forces captured Cherbourg in June 1944. German demolitions had destroyed traditional loading equipment, including cranes and winches. American engineers brought in forklifts and portable ramps. Within 3 days, they were discharging ships. Within 6 weeks, Cherbourg exceeded its pre-war capacity. Lieutenant Colonel James Whitfield noted in his after-action report, "Our mechanized approach made traditional equipment obsolete. German commanders had assumed port damage would limit American supply capacity for months. Instead, American forces maintained offensive operations without apparent supply constraints. This revealed a broader philosophical difference. American military logistics approached problems with industrial solutions, while German logistics remained rooted in traditional military thinking. Where Germans saw destroyed cranes requiring specialized repair, Americans saw opportunities to deploy forklifts and temporary structures. These differences had roots in national industrial cultures. American industry, in the 1930 seconds, had embraced mass production, interchangeable parts, and mechanization across virtually all sectors. The automotive industry particularly had developed systematic approaches to moving heavy components efficiently. When war came, these industrial methods transferred naturally to military logistics. German industry, despite advanced technology in many areas, retained more traditional manufacturing approaches. Craftsmanship, custom engineering, and specialized skills remained highly valued. German methods prioritized quality over quantity, precision over standardization. These cultural preferences produced excellent individual products, but couldn't match American systematic efficiency at scale. The forklift exemplified this perfectly. German engineers could design excellent cargo handling equipment, but Germany never systematically deployed such equipment across its logistics infrastructure, never developed supporting systems like standardized pallets, never trained large numbers of operators, and never integrated mechanized handling into military doctrine. Operation Overlord required landing and sustaining multi-million-man forces across the English Channel. Pre-invasion planning calculated that maintaining offensive operations would require approximately 40,000 tons of supplies daily. Traditional cargo handling calculations suggested this was barely achievable, even with optimal conditions. Mechanized handling transformed these calculations. Liberty ships, arriving off Normandy, were met by specialized LST vessels equipped with portable ramps and forklifts. Palletized cargo transferred directly from Liberty ship holds to LSTs, which ferried loads to beaches where more forklifts received and distributed supplies. By mid-July 1944, Allied forces were landing over 50,000 tons daily, exceeding pre-invasion estimates by 25%. Ships discharged faster, supplies moved inland more quickly, and the entire logistics pipeline operated with greater throughput than planners had thought possible. German forces faced opposite realities. General Major Fritz Bayerlein of Panzerlehr Division later described his frustration. "We calculated that American forces would outrun their supplies within 10 days of breaking out from the beaches. Instead, they maintained pressure continuously. Their entire logistics operated like a machine. Our horses and wagons couldn't compete with their trucks and mechanical handling equipment. An American quartermaster, company with 20 to 30 forklifts, could handle 5,000 to 8,000 tons of cargo daily. A German division supply service, using predominantly manual methods, handled perhaps 1,000 to 2,000 tons daily. This 3 to 4 to 1 efficiency advantage meant American forces could sustain operations that German logistics couldn't have supported. The Red Ball Express, the famous truck convoy system that supplied advancing American forces in August-September 1944, moved over 12,000 tons daily over distances exceeding 400 miles. Without mechanized cargo handling at both source depots and forward distribution points, the entire system would have been impossible. Traditional manual loading would have created bottlenecks that negated fast truck transport. The Pacific Theater demonstrated similar patterns with even more dramatic effects. Distances dwarfed European supply lines. Traditional logistics calculations suggested that sustaining large forces across thousands of miles of ocean would be impossible. Yet, American forces island hopped across the Pacific while maintaining supply levels that astonished Japanese defenders. Vice Admiral Motomi Ugaki wrote in October 1944, "The Americans land supplies on beaches as though unloading at peaceful ports. Their mechanized methods move cargo ashore faster than we can unload at our established bases. This efficiency, combined with their production capacity, creates insurmountable advantages." The invisibility of these decisive factors proved strategically significant. German and Japanese military leaders focused resources on countering visible threats: aircraft, tanks, ships, and fortifications. Relatively little effort went toward understanding or countering Allied logistics systems. The assumption remained that wars were won by combat forces, not supply chains, that traditional military virtues mattered more than industrial efficiency. These assumptions proved fatal. By 1944, Allied logistics advantages were so overwhelming that Axis forces couldn't win regardless of tactical performance. U-boat crews saw endless Liberty ships, but didn't understand the cargo handling systems that kept those ships continuously loaded and sailing. German soldiers captured American supply dumps but couldn't replicate the systematic efficiency that created such abundance. Between 1941 and 1945, American ports handled over 300 million tons of military cargo. German ports handled approximately 75 million tons during the same period. The 4-to-1 advantage reflected not just Germany's smaller economy but fundamental efficiency differences. By 1945, American military and civilian organizations possessed over 180,000 forklifts. German forces possessed fewer than 5,000 total. The 3-6-to-1 American advantage in this single equipment category symbolized broader logistics disparities that determined strategic outcomes. For U-boat commanders, understanding these statistics provided bitter clarity. Fregattenkapitän Otto Kretschmer stated, "I believed we were fighting naval warfare where skill and courage would determine outcomes. We were actually fighting industrial warfare where production capacity and logistics efficiency mattered most. Mathematics defeated us more than any specific Allied weapon or tactic. U-boat casualty rates in 1944 exceeded 80%. Of 46,000 men who served in U-boats throughout the war, 30,000 died and 5,000 were captured." Oberleutnant Werner Henke wrote in his final patrol diary before his boat was sunk, "We sink too. They build 90. This is not warfare. This is futility." The logistics methods developed during the war, mechanized cargo handling, palletization, systematic loading procedures influenced post-war commerce and all subsequent military operations. Modern container shipping represents the logical evolution of palletized cargo and mechanized handling pioneered during World War II. For military historians, the forklift story illustrates how seemingly minor technologies can have strategic impact when systematically deployed. The 2,710 Liberty ships that helped win the Battle of the Atlantic depended on forklifts to make their mass production strategically meaningful. The humble forklift, moving pallets on docks far from combat zones, contributed more to Allied victory than many celebrated weapons. German submariners, elite warriors of the Kriegsmarine, fought magnificently and died bravely opposing an industrial system they never fully comprehended. While they focused on combat excellence, Americans were perfecting logistics efficiency. While they refined torpedo tactics, Americans were training forklift operators. The lesson was undeniable. Modern warfare rewards systematic efficiency over individual excellence, industrial capacity over tactical skill, and logistics superiority over combat prowess. The 2,710 Liberty ships killed the U-boat Wolfpacks through sheer overwhelming numbers, enabled by rapid construction and even more rapid loading, and enabling that loading were hundreds of thousands of forklifts operated by workers who transformed warfare without firing a shot. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.